section 5.1, using fundamental identities. Really cool thing we start in chapter 5. I know you're all excited about this, so I'm just going to cut right to it. We get to write proofs. But they're not the geometry proofs that you remember and love and cherish so dearly from geometry. They're not that 2-column given, all that stuff. They're more algebraic proof. So how we're going to accomplish those is mainly through these two tools. Substitution and simplification. All right? So substituting in equal amounts that look different so that you can then cancel out terms, combine terms, simplify down. And these are going to be our formulas. These are going to be our substitutions. And you're going to have access to these throughout the entire chapter. Okay? So the identities. An identity means that two things are equivalent. They are the same. They're identical to each other. So sine of an angle is equal to 1 over cosecant of that angle. Okay? It's a reciprocal identity. Sine and cosecant are reciprocals of each other. Cosine of an angle is equal to 1 over secant of that angle. Tangent is equal to 1 over cotangent. And then you see that for the reciprocals as well. So these are pretty helpful. Let's say you have sine of theta times cosecant of theta. Well, cosecant is equal to 1 over sine. So we can substitute 1 over sine in for cosecant. When we multiply these together, those cancel out, and you're left with just 1, which kind of makes sense. Sine and cosecant are reciprocals. When you multiply reciprocals together, they should cancel out and leave you with 1. The quotient identities. Okay, if you remember, sine was y, cosine was x, tangent was y over x. So if tangent's y over x, if y is sine, x is cosine, then tangent is sine over cosine. Cotangent is cosine over sine. So let's say you have tangent of theta times cosine of theta. How could we simplify that down? Well, by the quotient identity, tangent can be replaced with sine over cosine. That cosine is technically over 1, so let's multiply, cancel out. Leaves you with just sine of theta. And then we have the Pythagorean identities, okay? Now these Pythagorean identities, these are fairly helpful whenever you see values that are being squared, all right? Squared and added. Now, if you think back to a right triangle on the unit circle, we have x, y is on the unit circle, so it's 1. Now, Pythagorean theorem, x squared plus y squared equals 1 squared. Well, x is the same as cosine. Y is the same as sine. So the Pythagorean identity is representative of the Pythagorean theorem. And we have a couple other versions of that as well, okay? The original Pythagorean identity is equal to 1. This next option is equal to secant. So think, how did we manipulate this? What did we do to this to turn it into this? And I'm really focusing on this 1 turning into secant. What would you do to 1 to turn it into a secant? To do that, you would divide by cosine squared. Now, whatever you do to one side, you got to do to the other side. So sine squared over cosine squared. Now sine over cosine is tangent. So sine squared over cosine squared gives you tangent squared. Cosine squared divided by itself gives you 1. 1 over cosine squared reciprocal gives you secant squared. So it's an alternate Pythagorean identity. To take this 1 and turn it into cosecant. Okay, how would you do that? What would you do to 1 to turn it into cosecant squared? You would divide by sine squared. And then what you do to one side, you gotta do the other side. I don't know if I did this last time. I think I messed it up, but now I'm noticing it, and it's gonna bother me. I won't be able to sleep at night. I'm gonna change these all into U's. I don't think I did it on the previous example, but I already recorded it, so I'm good with letting that one go. So sine squared divided by itself, that's gonna give you the 1. Cosine divided by sine. Now cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. And 1 over sine squared gives us cosecant squared. So whenever you see the number 1, you see things being squared and added, that should kind of give you a red flag, hey, I think I want to do a substitution from these Pythagorean identities. The cofunction identities kind of come up, and really what you're looking for is somewhere in the problem, do you have pi over 2 minus an angle? Pi over 2 minus an angle, that's going to be like, hey, red flag, use a cofunction identity. And then the evens, odds, do you see a negative inside parentheses? That's like, hey, probably going to use an even-odd identity. Now you have access to these all throughout the chapter. You want to keep referring to them. They really are your formula sheet. They're your reference. You want to use them because you want to keep looking and seeing where can I make connections, where can I make substitutions that will lead to simplifications. Now here's kind of some guiding principles, okay? In order to simplify these down, because simplify, like the directions, simplify, are actually very complicated. There's a lot of different ways that could look. There's no like one correct way to do it. There's a bunch of ways you can do it, and depending on the problem, sometimes you do a move, sometimes you don't. So I want to try and give you some guiding principles here, okay? So number 1, reduce the amount of terms that are present. So if there's sine, cosine, and tangent, could you get it all just in terms of sine and cosine? Or maybe all in terms of tangent or all in terms of sine? Reduce the amount of different terms. And then in general, fractions usually aren't very simple. So you want to try and get rid of any fractions that may be present. Okay, so let's give this a shot. See how it goes. I cannot stress this enough, and I talk about this when I teach proofs in geometry also. The best thing you can do is to try something. See if it works. Write it down in pencil, lightly. Don't like take out your anger on the paper and make little indentations and break the pencil and then just like, and you get like this vein coming out of your forehead. Try something. Write out the result, see if it works. If it does, great, keep going. If it doesn't, erase it, go back, try something else, okay? The more you try these, the more you practice these, the more familiar you get, the more you're like, hey, I've seen a problem like this before and I did this. Let's see if that works again. So sine of x, cosine squared of x, minus sine of x. So there's no fractions, that's good. Okay, I'm thinking, I see this cosine squared, and that immediately makes me think of the Pythagorean identities. Now, the Pythagorean identity, the OG, is sine squared of x plus cosine squared of x equals 1. Now I want to replace just this cosine squared. So I'm going to manipulate this a little bit to get cosine squared by itself. Let's subtract sine squared from both sides. So we have 1 minus sine squared of x. So I'm going to replace just this cosine squared with 1 minus sine squared. I'm going to try something and see what happens. Now, there weren't any fractions to get rid of. That's cool. Reduce the amount of terms present. I did have sines and cosines. Now I just have sine. That's good. I got that 1 also, but I can get rid of that 1 just by doing some distribution. Now look at the result and see what happened. I have sine minus sine cubed minus sine. So sine and negative sine cancel out. I've reduced down to a single term. And I think I got a pretty simple expression. More simplified than when I started with. Now, there is no one right way to do these. Okay? You usually want to get down to the same answer, but the order of your steps and the steps you use may be different. For example, looking at this original problem, this term has a sign, this term has a sign. Well, if this has a sign and this has a sign, I could do a greatest common factor. That would leave me with cosine squared of x minus 1. All right? So I have cosine squared of x minus 1. Now 1 is equal to sine squared plus cosine squared, the Pythagorean identity. So let's do that substitution. Well, when I look at this result, I see cosine squared minus cosine squared. Those cancel out. Leaves me with sine of x, negative sine squared of x. When I put those together, I get negative sine cubed. Same answers, 2 different ways to do it. So I cannot stress this enough. Try something. See if it makes your life easier. If it does, keep going with it. And if it doesn't, erase what you did and try something else. So I got a whole bunch of practice here for you to look at. You can try something.